This lesson is called How to Not Make a Fool of Yourself, or How to Estimate.
Yay!
So last night, after creating our most recent Edmodo video, Brian and I were all ready for bed, and we were nodding off to sleep. And all of a sudden, my eyes popped open, and I thought to myself, "Oh no!" which promptly woke Brian up.
What the?
And I realized I had done something very, very wrong.
Uh-oh.
Ah! I had a brain fart. If I had really thought about the numbers and bothered to ask myself, does this make sense? I would have quickly realized, no, not on your life, not on this planet, not in this century, absolutely not. So, feeling pretty silly about myself, I figured that I would take this grand opportunity to teach an all-important lesson that can keep you from making a fool out of yourself by estimating first. If I had just taken 30 seconds to think about the numbers, I would have been able to make an estimate first that would have kept me from embarrassing myself later. So here's what I should have done. I should have thought to myself, well, $1,029 is pretty close to 1,000, close enough. And 18 students, well, that's pretty friendly if I'm multiplying by 1. So I could keep that the same. I could also change it to 20 students, a very, very friendly number. But really, if I'm working with a 1 over here, anything's friendly with a 1. Lucky for me, I know how to cheat with zeros, so when I quickly multiply those together, I would get about $18,000. That's really how much they needed to fundraise, about that much. And even that we know is an underestimate because 1,000 is actually less than the actual amount that each student needed to earn in order to go on this Washington, D.C. trip. So really, when you figure it out for real and get the accurate answer, you find that $1,029 times the 18 students is exactly $18,522, which is a pretty big difference between my $11,522. That would mean that if the school only raised this amount, too bad, so sad, they don't have enough money to go on the trip. That's why math is important. So what I should have done is I should have bothered to take 30 seconds to do a quick friendly number estimate so that I could ask myself, does this make sense? Yes. You can check back to the original estimate, and if it's pretty close, looks like it'll make sense, and it's most likely the correct answer. Pause this video right now so that you can copy down this exact slide into your notes, cartoon drawing and all. Press pause now. Now, I don't want you to feel like, oh my gosh, I have to solve the whole multiplication problem and I have to estimate. Estimates are meant to make your life easier. Yes, I said it. They should make your life easier. So, some tips for estimates that will make your life easier and not take up too much of your time. 30 seconds or less. You should use friendly numbers, not numbers that are difficult to work with. And your numbers that you use in your estimate should be pretty darn close to your original numbers. That way, you can ensure that it's not going to be way off from your final answer, and it'll be something that's pretty reasonable. And you can say, does this make sense? Yes! Let's take a look. Write this problem down as an example. So let's say that we had, we've got a lot of people absent right now. So let's say that we had 26 students that qualified to come to our tailgate party. And Mrs. Telestay wanted to make sure that we have enough soup for all of them. We know that each student is going to have about 8 ounces of soup. So how many ounces do we need to cook altogether? If you really look at those numbers, a reasonable thing to do might be to say, well, let's say it was 25 students, and that actually works very nicely with my 8 ounces of soup each. I don't really need to change that. I know that 4 groups of 25 equals 100, and I can double that to figure out what 8 groups of 25 would be, and that would be 200. About 200 ounces of soup. Now, a careful planner would also say, well, that's an estimate. Is it an overestimate? Am I going to have too much soup? Or is it an underestimate? Am I going to have too little soup? Because we originally had 26 students, but this only counts 25 of them, I know that 200 is going to really be an underestimate. So be sure to write that down. And I will keep that in mind to make sure that I have more than 200 ounces of taco soup for our tailgate party. Now we can apply the same concept for rounding and looking at friendly numbers and using our strategies to make 30-second estimates for numbers that are lots bigger than that too. Let's say that a jumbo bag contains 587 M&Ms. And Mrs. Schneid was feeling very generous, so she went out and bought jumbo bags for all 38 classes at Siena. How many M&Ms is that in all? Well, this is a multiplication problem. So let's estimate. 587 M&Ms, that's about 600 M&Ms. And 38 classes, that's about 40 classes. You'll notice that in these estimates, I ended up just rounding to the greatest place. In this case, I rounded to the hundreds place. And in this case, I rounded to the tens place. Now, these two numbers are numbers that you should be able to work with in your head. Fast fact, 6 times 4 is 24. And I've got 1, 2, 3 zeros to place at the end if I cheat with zeros. So we have about 24,000 M&Ms. Woo, that's a lot of candy. Now ask yourself, be reasonable here. Is this an overestimate or an underestimate? Well, since we rounded both the number of M&Ms and the number of classes up, this would be an overestimate. So we're not actually going to have quite 24,000 M&Ms floating around in our school, but we'll have close to that amount, but the actual amount will be less. Sometimes when you estimate, you're going to choose to leave some numbers exactly as they are. With 1-digit numbers, we're usually going to want to leave them like they are, because if we can get our multi-digit number to something that's friendly, we can multiply it by any 1 digit. Sometimes also we're not going to just round to the nearest or to the greatest place. Check this out. If I was observant and I looked at this 4, I might say, ooh, I could get to the power of 100 by changing 263 into 250 and leaving the 4 the same. Because now I've got 25 times 4, which is the power of 100. And I've got one more 0 and a factor, so I need to place one more 0 in my product. And I place my comma, and I've got about 1,000. If I just wanted to round to the greatest place, that's also quick. It's pretty close. I would now have 300 times 4. So 3 times 4 is 12, and place 2 zeros. I would have gotten 1,200. So my first estimate was an underestimate, and my second estimate was an overestimate. Which one is closer? How could you figure that out? Well, take a look at the number that changed. In the first case, the 263 became a 250, which means that there was a difference of 13. Now take a look at our 263 changing over to 300. That is a difference of 37. 37? Yikes! That's a much bigger difference than our difference of 13 over here. So, if you're wanting to pick the most reasonable or the most accurate estimate, I would think that 1,000 would be more accurate than 1,200. Both of them are efficient and should be enough to check your work and make sure that you don't have a huge blunder that's, well, 8,000 off, like mine yesterday. So, here's your task. When given the problem 113 times 85, Georgie, Jamie, Tommy, and Benji, aka George Washington, James Madison, Thomas Jefferson, and Benjamin Franklin, got different estimates. What you need to do is you need to figure out how they tweaked those two original numbers in order to get their estimates. In other words, how did Georgie change 113 and how did he change 85? So figure out how these lovely founders and framers estimated, and one more thing, solve the actual problem and get the actual real exact answer. Figure out who was closest and tell how you know. And that's it for how to not make a fool of yourself or how to estimate.